Log panel. Speed in. Auto panel. Warning. Level 3. Auto game.
Okay, so how's it going? Good. Assignment 5 was an easy one? Yes-ish? Okay. Assignment 6 is also not super hard, but it takes some time, and it's something brand new for you, so please go to the tutorials, learn what you can there, and then work hard on assignment 6, get started early. And that's sort of your training in getting things done in pygame. So we have started, last class we sort of flexed our muscles a little bit, learning how to do a couple of things with pygame. So at this point, I think probably the best strategy to keep learning is not just to go through an exhaustive list of the features of pygame, but rather to build something with it. Something that's not just some funny little demo, but a real kind of game. And then we'll sort of learn the features as we go along. So I've got a skeleton game here that does, again, nothing. The only thing you can do in this game is exit. So we'll need to do something with that. Yes, that's you win if you can do that. And I have, aside from that, I have a vision of the kind of game that I would like to make. So you sort of have to start with some idea of something you'd like to make. And I'm thinking of something that's not exactly a clone, but it's a throwback to these old Missile Command type games. Yeah. It'll open within the hour. Yeah. Okay, you want to work along with me. Should work now. Yeah? Okay. All right, so I want to do something like these old missile command games. All right, could you guys stop talking if you're talking now? It's my turn for the next little while. So I'd like to do something like one of these old missile command games, which you may or may not have played. Typically, these games look something like this. Game screen looks like, well, rectangular. There is, something down here, and there's some bases. Your job is to protect these bases, and you launch missiles from different places. I'm not sure where I want to launch them from yet, so maybe we'll start by launching missiles from here. And there's incoming missiles. So missiles come down from the sky, and they want to blow up your bases, like that. Your job is to intercept them with missiles of your own, and have your missiles explode at the same time as theirs, or explode before those ones get to your bases. And once your bases get damaged enough, then they blow up, and that's the end of them. And the controls are fairly simple, which is nice because it means we can do this basically with a mouse and one button, or on something like a tablet. It's just one finger pressing the screen. You just click somewhere on the screen. That fires off a missile, which, when it arrives at that location, the missile will explode. And so you got to time it just right so that your missile gets to that location and explodes at the same time as some enemy missile is arriving at that location. Yeah?
Would it be too complicated that it has to hit the actual missile, and if it doesn't, it just keeps going?
It wouldn't be any more complicated, but it'd be frustrating as hell. Because the missiles are pretty small compared to to make it playable, you want the explosions to be a fair size to catch stuff in the area. Yeah?
Say if instead of allowing to hit that specific spot, what if it intercepts it once?
So again, it's coming along like this, and then this guy's coming along, and they both happen to be at the same place at the same time. So that's, to have them exactly the same place at the same time would be, again, really difficult to do. You could, if you wanted, this is the kind of thing that you add later is, better missiles would be ones that just blow up whenever they're close enough to something that, to kill it. So that, that could be, as the game progresses, if you earn some, you level up, you get better missiles that do stuff like that. But for now, I want to start with something easy. Missile goes where it's supposed to and explodes. Then you can think of guided missiles, whatever, where you just click on the thing you want to blow up and it follows it and kills it. There's lots of options, but let's start with something easy. Okay. So that's what I want to start with, and so that says we've got things like bases. That's something we've got is these guys here. This is a base. You're supposed to protect it. We've got definitely got missiles, and maybe we've got two kinds of missiles. I don't know, the regular missiles, the ones we launch, and maybe incoming missiles. So if we're thinking about objects, these are the kinds of things that we would think about. All right, and remember, our screen coordinates are such that Our screen coordinates are such that the top left corner of the screen is 0, 0. X coordinates grow to the right, and Y coordinates grow downwards. Yeah?
You need like a fire rate too, right? So you can't just shoot a million of them.
we'll see. See if we need to limit that. That's a question of playability. So maybe at the earlier easy levels, you can shoot as much as you can fire as much as you want. But maybe later you run low on missiles. We'll play with it a bit and see what works. All right. So this is a sort of a tall order. There's a lot of things here already, and it's hard to know where to start. And so usually, well, there's lots of things we can do. We can draw the screen and carefully do all the artwork with the bases and stuff first. But usually that's not the best way to do it, because what you can find happening is that your vision for the game, once you start playing it, you realize there's some problems that you need to adjust what you thought it was going to be, and that can mean that the artwork needs to change significantly, and so you end up doing artwork over and over. So it's better to start with what are called the mechanics of the game, where you implement the gameplay features, see how they work, get them going in a very rudimentary way, and then at the end is when you do the polishing, the fine artwork, and so on. So it seems that really the first feature of this game is just the ability to launch missiles, and that's what we would like to implement first. And missiles are sort of a natural kind of object. They're sort of a natural thing, and so we might as well define a class for missiles. So what sort of properties do missiles have?
Velocity?
A velocity. So, or speed, or whatever you want to call it. So I'll say, for now at least, until we have reason to believe otherwise, all the missiles we launch will have the same speed. No reason to think that any one should be any faster than any other. So with the missile class, I'll define a variable called speed, and I'll set it to 4. And for us, although this isn't the best idea, the most portable idea, it'll be good enough for what we're doing. Speeds and things correspond to pixels per frame. So these missiles will travel maybe 4 pixels per frame. So not very fast, although frames happen 30 times a second. Yeah. Yeah, you'll want a self in init here, and other things. So a missile has a speed. What else?
A vertical and horizontal component of the speed?
Well, I don't really want to do that. So that's something we can calculate later. But from the description of the way you launch missiles, somehow, what are the properties of this thing? Yeah. Launch angle, too specific. Size. Sure. So let's say size, and I don't know, maybe missiles are also 4 pixels in radius or something. Yeah.
Starting point?
A starting point. So let's say something that they start from. So some place where they start. So when you initialize it, you say, launch the missile from this location here. Yep. Missiles will explode, so maybe we would want some kind of something for explosions. We'll see that. Let's see if we can get one launched before we blow it up. Yep. Target. Right. So the way that the way you specify a missile is you click on where you want this thing to go and explode. Yep. Yeah, but again, that's all stuff that we can add later. Let's keep it simple for now. Yep.
Will we put like image that we want to use inside the class?
Yeah. If you're going to load an image of a missile, then you'd put it inside of this class, and we'll end up doing that a bit later. But for now, we'll cheat and make our missiles really cheap. just circles basically. Yeah.
Does the target need to be X and Y coordinates?
Yeah. So so I don't say what the kinds of things these are, but these will be pairs of coordinates. So start will be a tuple or a list of length 2, and so we'll target. So a missile, once it takes off, it doesn't really care about its start position. It just cares about where it is right now. So right now, when we launch a missile, this is where it starts. And here we just use this, this set copy notation so that we're going to take a copy of these list of coordinates. There will only be 2 of them of start, and that'll become the position of this missile. We're taking a copy of it because we're going to change it, and so we want this to be our own thing, specific to this particular missile. And we'll also save the target. Okay, so that those are the 2 basic parameters that are specific to this missile: the speed and the size. Well, that all missiles will have the same speed and the same size. Yeah.
So I'm just a bit unclear on why you used like the set, or not the set, but the list notation after start.
Yes, that's just because remember that if someone passes us a list as an argument, then what they're really passing us is a reference to a list. Okay? So I intend to take this position here, and as the missile moves, this position is going to change. So that means I'm going to change the values that are stored in that list. And that means I want those to be mine and not shared with anybody else. So they're going to be specific for this object. So this says, take this list that was given to me as input, copy it, it's my own thing, and now I'm referring to that. Any changes that I make won't be reflected in someone else's copy. It's just it's a precaution, just to make sure that we don't end up with a bunch of missiles that somehow all reference the same position, and then we'll have a big mess that'll be difficult to understand what's going on. And in fact, maybe we should even do that with target. Just say, this is our own data. We don't want anybody else sharing this with us. Okay. All right. So that's the missile initialized. All right. So let's see if we can make one of these things. So if we go back to the game initializes itself and then enters an event loop. And the event loop looks at a couple of different kinds of events. Either it quits, or there's the refresh event, in which case it should redraw itself. What's the event we need to handle for what we want to do?
Mouse click?
Mouse clicks. Okay. So we want to handle another kind of event. And that is the event type is equal to pygame.mouse button down. And if we go and look at the documentation, pygame game event. We look at all the different kinds of events. Mouse button down, those kinds of events come with 2 things. One is position and the other is button. So we don't care, for now at least, we don't care which mouse button is down. Any mouse button will do. In particular, maybe we want to even work with computers that only have one button on their mouse, so we won't bother with that. But this position is pretty important to us because it tells us where the user has clicked. Okay. So, all right. So let's say target is position.x, position.y. That's where the user has clicked. That's the target we want to launch. So we want to create a new missile. And we need to specify a couple of things when we create a new missile. That is the starting location and the target. All right. So the target's easy. We've got that captured. What about the starting location? Where should that be?
Where was it in your picture?
Well, in my picture, it was at the bottom of the screen in the middle. So where's the bottom of the screen? Yep. Yep, so the bottom of the screen will be at the height of the screen, which is 600. So let's say the second coordinate, the y coordinate, will be self.height. And how about the middle? That's self.width divided by 2. Okay. So we're specifying two arguments to the missile. The first one is the tuple, which is the width and the height, or the width divided by 2 and the height. So that should be the bottom middle. And the next one is the target. And let's say see if this is working for us. Missile launch at position. So I'll click somewhere. Global name position is not defined because it's event.position. And since we've already stolen those and put them in target, target at 0, target at 1. So if I click somewhere, tuple has no attribute named x. Oh good, it's even better. Position is also just an array, a list.
Why can't you just put that directly into the missile?
We probably can. Okay, 570, 210, and let's map the screen. So up here should be pretty close to 0, 0, yeah. Over here should be big X coordinate, small y coordinate, yep. Down here, big X and big Y. And down here, little x, big Y, so the bottom of the screen. Good. So we've done this and we've created this missile and sent it to the right location. And so the question now is, why don't we just streamline this a little bit and say target is just the event.position. All right. So is it enough just to make this missile? Should we do something else with it? So what happens if I just make a missile here inside this M, inside this loop? What happens to it? Yeah?
We need to make something like it so it increases the utility for that coordinate.
Sure, we need that, that the missile moves, but right now all we're doing is making this missile, putting it into this local variable, and then it just goes away. We didn't really save it anywhere. It's just in this local variable, it's gone. And if we think about this, well, eventually we'd like to have lots of missiles and lots of things going on. So it seems that our game object should have a property, which is all the missiles that are currently active. So let's say, one of those things that we'll keep is a list of missiles. So we start with an empty list, and self.missiles.append, yeah. So we put this new missile on the list of missiles we're keeping track of. All right. All right. Well, so we created this missile and we saved it. So now we're going to have a big list. If we keep clicking around, we'll get this big list of missiles. What do we need to, I don't know, to get this started, what do we need to do? Some kind of graphics, right? Right now these missiles are just there, stored in the game, but there's no code at all to draw them. So we know that every 30 times a second, there's this draw routine that's called that is supposed to draw everything. And so in particular, it should draw all the missiles. So now I'll say for M in this list of missiles, I'll draw M on the screen, on self.screen. Self.screen, as remember, is the window. So that means missiles, since M, all these M's are from the class missile, we'll need to make a method called drawOn for these guys that draws these things. And let's keep it simple for now. So back up in our missile class, we have a drawOn method that takes one argument, which is the screen that they should draw themselves on. And let's keep it simple and say, just draw them as a circle. So there is a pygame draw a circle that needs the surface you're drawing on, the color, the position, the radius. Okay. So pygame.draw.circle, draw it on the screen. The color can be red. So let's say the color of all our missiles will be red. That's all red, no green, no blue. So color, position, radius, and width. Position, we've got self.position. And radius is self.size. And width, we see here that there's a default width argument of 0. The width is for drawing, I believe, a sort of circle around the circle. So the actual circle, and then the disk gets filled with this color, but we'll accept the default width of 0. So let's see if that works for us. My game object has no attribute named missiles. Missile, and I need missiles. Okay, so let's launch a missile. This is one drawback of programming in 2 languages at once. Is in many other languages you don't have to say self in front of everything. In Python you do. Anytime you access a member of an object, you have to specify self. That's what I forgot to do there.
Couldn't self be up there too?
Up here? In this section, you mean?
Yeah.
No. So when you define variables inside a class but outside of any function, they become what's called class variables, which are shared by all instances of that class. So in this case, you don't need to do that. All right. So click there. So I launched a missile. Do you see it? Yep. Started out right there at the bottom. Now, missiles don't do anything else yet. They get launched and they they get their starting location and then nothing else happens. So indeed, this missile is being drawn. I'll launch another one, and another one, and another one. So lots of missile launches, but they're all stuck there at that bottom location. So what should we do next?
Calculate the angle using pygame too.
Well, let's not get too far ahead of ourselves. But so why did you want to calculate the angle?
So it goes towards the house.
So we want it to go towards the target. We want the missile to travel towards the target. So that means we actually need to do a little bit of algebra. So it's at the current position, and we want it to go towards the target position. Both of those things are points which have x and y coordinates. And so let's see. We're at some current position. I don't know. Position, which has two coordinates, 0 and 1, and we're trying to get to some target. And we would like to go, what we really want to do is move that far. So that distance there is speed. So in one frame, that's how far we want to move, that distance, and we want to move towards the target. So, you guys took some kind of algebra in high school. How do we do that? What's that? No, easier than that. Yep.
So the missile x plus equals the speed of the
Plus equals what?
the speed and then
The speed and what? The speed is just a number.
Speed multiplied by the sine or cosine of the angle, depending on if it goes vertically or horizontally.
No, we don't need any sines or cosines. Let's think this through. So we have position and target. So this is the direction we would like to go in. So it has two components. There's an x component and it has a y component. Here's target. Here is position. So probably the first thing we want to do is figure out this x and y component. Okay? So, and we'll call that thing, where are you? This vector here, we'll call it v. It points from position to target. So let's figure out this v. It has these two x and y components. So there we are. So every 30 frames per second, we're going to tell this missile to advance, get closer to its location. So once every 30th of a second. So we want this vector v, which points from the target, from the current position to the target. So how do we do that? Well, let's do it the long-handed way. V at 0 is equal to target at 0 minus position at 0. And let's not forget all our selves. And V at 1 is equal to target at 1 minus position at 1. Okay. So now V is actually this vector here that points from position to target. In fact, if we did something like this, So to move from the current position to the target, we would say something like self.position at 0 plus equals v at 0, self.position at 1 plus equals v at 1. That would have position move directly to target. Now, is that what we want? No. We don't want to go there in one step. We want to go just a little bit of the way there. We want to take this little step here, whose length is only speed. So we really want to go just this far. So what we really want to do is take this vector and shrink it so it's only a little step. So how do we do that? We need to multiply it by something to scale it. What do we need to multiply it by or divide it by? What if we wanted it to be just equal to have length 1? So we have a vector that's really long, and we want it to have length 1. We divide it by its length. Okay? So we need to figure out the length of the vector. So norm is equal to v at 0 squared plus v at 1 squared. And we take the square root. This is the length of v. And now we would like to shrink this thing down to have length 1, and then blow it up again to have length 4. So that says we want v at 0 equals v at 0 divided by norm and multiplied by self.speed. So dividing by norm shrinks the vector so it has length 1, and then we multiply it by self.speed so that its length becomes 4. Right? This is the formula. In fact, someone said Pythagorean theorem, length of the for the length of the vector v. Okay. Clear? Good. All right, so we have this function inside our missile class called advance. And when do we need to call this advance function? Every tick. So back to the game. Every 33 milliseconds, we end up doing this thing. And so what we want to do then is for each missile, we want to advance it, and then we draw. Okay, so we go through our list of missiles. For each one, we tell it to advance, and then once that's done, we redraw everything. So let's give that a whirl. Self.missiles. Self.target. V is not defined. Where is V not defined? At line 30. Again, tuple object does not support item assignment. That is here. That's why we didn't want to do that. So since we passed start in as a tuple, when we copied it, we got another tuple, and you're not allowed to change tuples. So let's just make it a list. And integer argument expected got float. Okay, so this is an important one. Draw circle is not happy that we gave it a floating point argument. And of course, we're giving it a floating point argument because we're doing all these calculations here on the position, which now there's no reason, I mean, we compute a length, we divide by that length. There's no reason anymore that the positions are going to be integers. So when we draw this circle, we'll want to fix that and say position is equal to integer x for x in self.position. So just take all the coordinates and convert them to integers before we call draw circle, because draw circle is unhappy with non-integer arguments. And there we go. So we got this working. Okay, so works perfectly, right? So the question is, why is it shaking? It's because we told it to shake. I mean, it's doing exactly what we told it to do. When we create these missiles, we record a target. And each time we advance, we move a little bit towards that target. In fact, sometimes we overshoot the target. Because we always move a unit of exactly 4. And so when we get close to the target, we overshoot it. And then we turn around and we come back in the other direction to get close to it. But we overshoot it again because we're already too close. And then you get this wobble back and forth where these things just float over the target like this. Okay? But this is what we told it to do. So that's good. All right. Now what?
Only define the amount it's supposed to go once.
What's that?
Only define how much it's supposed to go in X and Y direction once. And then keep it like that.
Okay. No, I don't want to do that, and there's a good reason for not doing that, which is if I define that vector v once, then when I add v to itself a whole bunch of times, I will get some accumulated error happening, and the thing won't actually finish at the target. So there's a little danger of doing that. But, I mean, is there anything wrong with what's happening right now, or is it just not complete yet? I mean, what's supposed to happen? Right now, we have this problem. When it gets to the target, it starts jiggling back and forth. Yeah, it's supposed to blow up at that point. So let's just make it blow up at that point. All right. So in this advance function, we should blow this thing up, right? It would be good to at some point, when we realize we're close to the target, then we blow up. So how do we know when we're close enough to the target? What have we computed that tells us that? Yeah. Well, so you might say if self dot or position at 0 equals self dot target dot position at 0 and this, You might want to say something like that. Is that going to work though? Yeah.
It won't work because if that would work, then none of our missiles would be shaking in the first place.
Yeah. So we sort of already know that that doesn't work. And the reason it's not going to work is, well, we've already seen that the missiles are never exactly at the right location. They're always just sort of close. They're within 4 units of the correct location, but they're never exactly equal. And we saw even that these coordinates are floating point numbers, at least the coordinates of the position. And there's all kinds of problems with saying if one floating point number is equal to another one. In particular, we saw things like you take 0.3 and subtract 0.1, that's not equal to 0.2. We saw that already on the first day of class. So those kinds of equality tests are a problem for us. But, I mean, look at this code here in advance. Is there something in this code that would tell us when is a good time to blow up? Yep. Well, V0 and V1 are this vector, but what in particular about them?
How large they are?
How large they are, which is this thing here, the norm. I mean, norm is the length of the vector from position to target. And when is that close enough? Yeah.
When it's equal to or less than speed.
Yeah. So if norm is less than or equal to self.speed, then it's maybe time to blow up. Okay, so then we say, I don't know, self.explode. Otherwise, we keep advancing in the direction of this thing. Okay. All right. So this suggests now that our missiles, they have a position, they have a target, and maybe they also have some other data, which is what state they're in. So is the missile currently traveling towards its target, or is it exploding? So let's give some names to those states and say traveling, exploding, and initially when we create a missile, it's traveling. But when a missile explodes, then it changes its state to exploded. Okay? All right. So far so good. That changes the state to exploding, and maybe we should put some code around all this. If self.state equals traveling. So if we're traveling, then we do all this stuff to change our position. Otherwise, we're exploding. What should we do?
Make an exploding animation and remove the missile. Make an explosion, draw an explosion somehow. Is that something we would do in advance or somewhere else? Yeah?
For now, can we just make it disappear?
Make it disappear. Okay, so to make it disappear is easy. But where do we do that? Do we do that in advance? So advance is the thing that controls that decides where the new position is every frame or whatever.
Now we do draw.
We do it in draw on. So if the state is traveling, then we draw it as this little dot. Otherwise, for now, let's do nothing and just make sure we got things mostly working. So off it goes to its destination and blip, disappears. To its destination and boom, disappears. Good. So it's changing state to exploding and then disappearing. All right. So let's make it a bit more exciting. Let's actually draw the explosion. So this time I got some images beforehand. And I have a explosion.png. So every instance of missile will use the same image for an explosion. So we'll load that up here as a class variable. And so that's explosion image equals pygame.load.image images / explosion.png. So we've got this thing, and if the missile is currently exploding, then we should draw that image. So that, we've seen how to do that. We say we get the rectangle for the image we want to draw. Now we want to draw it at the current location or at the target location, let's say. And so we do screen rectangle equals rectangle.move. So where do we want to move this image to? Yeah. Yeah, you can use an animation as well. Then the way you do animation is every frame you change the image. But you can't just plug in an animated GIF. That won't do it. Yeah. So you get a sequence of images, and then every frame you change the image. What's that? No videos either. I mean, you make the video by displaying a sequence of images. Okay. All right, so where do we want to draw this image? So do I just say self.target at 0, self.target at 1? We can try. Pygame.image.load. And self is forgotten again, of course, in 2 places. No, because rect is just a rectangle that I only want for the duration of this function. I don't want to store that forever with the object. Okay. Does that look right? It's off. So why is it off? Yeah.
Because the top left corner is being drawn at that point instead of the center of the display.
Yeah, you can see the mouse cursor is still right there where I clicked it. It's really the top left corner of that image. You don't quite recognize that immediately because the the image doesn't fill its bounding box, but there is a transparent part of the image right under the mouse there. And we know how to fix that. You have to subtract off half the width of the image, and you have to subtract off half the height of the image. Perfect. Okay, good. So we've got these things exploding where they should. Still not quite the life cycle of a missile yet, is it? Yeah. What's? Yeah. I mean, otherwise we have a pretty good strategy for killing everything, right? Which is just to make a wall of explosions. That'll definitely protect our base from anything that's incoming. But these explosions don't last forever. So we'd like them to last some length of time. So again, that's something we should define. Let's say explosion duration. I don't know, maybe half a second is long enough for an explosion. So at half a second at 30 frames per second is 15 frames. And so at some point we explode this thing because we've decided it's close enough to explode. We change its state to exploding, and now we should start counting, because we only want to be exploding for 15 frames. So let's say, I don't know, counter. We start this counter at 0. And now when we advance, the counter should increase by 1. And we now sort of determined that there should be a third state of these missiles, which is they travel for a while, then they explode, and then they're done. So if the counter gets to be bigger than, what did I call it? Self.explosion duration, then the state should become spent. So we'll define a third state. Called spent. So when we're drawing, if the state is traveling, we draw a circle. If the state is exploding, we draw the explosion, and otherwise we don't do anything. So let's see if that works. We set the counter, we increment the counter on every frame, and maybe even here I should say okay, whoop. Half a second, gone. Perfect.
Is it possible to delete that instance of the class?
Ah, that's a good question. So this seems to be doing great, doing what it's supposed to do. But if we think about what's happening here, all that's happening is we've done everything so far, all of this state changing stuff, we've done it in the missile class. But we shouldn't forget that there's somebody else who's keeping track of all these missiles. And just because we set our state to spent and then we don't do anything anymore, I mean, then basically advance and draw don't do anything. There's still somebody else who's keeping track of all this stuff, and we should let them get rid of it, or they should get rid of it. So here. And that would be, for instance, right here. So we go through our missiles, we advance them, and then we draw everything. And then maybe we should say, clean this thing up. So which missiles do we want to keep? What's that?
Your state is high.
Yes. So, just at the end of this loop, we'll go through our list of missiles and get rid of any of them as long as their state is not spent. The spent missiles, they're done. That's it. They've traveled, they've exploded. They're not going to do anything for us anymore. We should take them out of our list of missiles. And this filters out, or filters in, keeps only the ones that are not spent. We can do this, yeah, we might as well do that right here. Okay? Maybe even slightly more efficient if we do it before we draw.
Why don't you do it inside the first so you don't have to loop it twice?
Because you cannot delete things from a list while you're iterating over it. That causes problems. Yeah? Can I explain what is? Oh, so yeah, so this just says I want to define 3 variables. So we've seen this tuple assignment before. I want to define 3 variables, traveling, exploding, and spent, and I want to assign them the values 0, 1, and 2. So you take a tuple on the left-hand side and a tuple on the right-hand side. It assigns the values coordinate-wise. And that's just because it's a lot easier to read code that checks if a state is equal to traveling rather than if it's equal to 0. You don't have to go back and think, oh, what does 0 mean again? What does 1 mean again? What does 2 mean again? Okay, good. All right, so we actually have some real some real mechanics there. This thing is working so far. What else could we add to this? Well, why don't we try and see if we can have missiles blow each other up. So already, even if there's no incoming missiles, we can still do that. And so let's see if we can make missiles blow each other up. So how would we do that? Yep.
We want to know if the position of one missile is close enough to the position of another missile.
Yeah, and what kind of missile? All the missiles, or which ones? Well, not enemy. Even if I launch 2 of my own missiles and they blow up right beside each other, they still blow each other up, right? So somehow it doesn't matter whether it's an enemy missile or an incoming missile or an outgoing missile, but it's really only the missiles that are exploding that we have to worry about, right? Okay. So let's see if we can do that. So that's in the game, because the game is the thing. Missiles don't know about other missiles. They're all sort of independent. It's the game that's maintaining this big list of missiles. So we advance the missiles, which means some of them start exploding. And the ones we care about is the ones that are exploding, right? Those are the ones we're worried about. Okay. So now we have a list of these exploding missiles. And for each guy in that list, we'll go through the list again. So we have a missile M, it's currently exploding. We have a missile M2, which may or may not be exploding, I don't know. So what do we do? Yeah,
Well, if the x of one minus x of another is small enough, then it's within range,
just the X
and the y.
and the Y. So if the distance is small enough? Yeah, so we'd say something like, well, maybe we won't worry about M2 if it's already exploding, because that's a possibility. It could be another one that's exploding. So if M2 state is traveling, and the distance between M's position and M2's position, if that is less than something, let's say 50, then we'll blow up M2 as well. We'll blow up this second missile.
Does pygame do hit passes?
There is a sophisticated, you can use a bitmap screen to tell if two bitmaps intersect. So you could use that. It's a little more than I want to get into right now. But yes, there is a hit test that you give it basically a pair of images with transparency, and it'll tell you if there are two non-transparent pixels that overlap. That's the best way to do it. But for now, we'll approximate it by saying if the distances are not too big. So then we explode M2, and so let's try that. Where did I forget self? So distance is not defined, and that's because, well, indeed, distance is not defined. So let's define it. Distance between 2 points. Let's say A and B. Let's try and make this quick. So the last thing you do is take the square root, then you take the sum of AI minus BI squared I and 0. Okay. Indeed, the explosions are spreading. Good. All right. So we've got missiles that work. Missiles will blow each other up if they get too close to each other. So now we have a few choices on what we can do next. We can make enemy bases, or we can make the incoming missiles. Let's do the incoming missiles. And let's do those just because they're actually quite easy to do now. So, I want to create a new class called incoming missile. Is this a whole new class? Is this something that I have to redefine from scratch?
No, it's just a missile.
It's just a kind of missile. So, sometimes I create a new one of these things, and I will maybe give it a starting position and a target. And someone else, so I can remember this funny notation. Basically, we just want this thing to behave exactly like a missile, maybe with a few small changes. So let's say we just pass this up to the missile class. That's what this funny super notation does. Says just do whatever the missile class would do with this. And maybe the only thing that we will change, just so we can tell these things apart, is well, actually the only thing we need to change is the color. We'll make these ones blue. Okay, so now we've got this new class, incoming missiles. Everything else about this class is the same, except the color is different. All right, somebody has to launch these missiles, and it's not the user by clicking the mouse. So when should these get launched? Yeah.
I just wondering, shouldn't the starting position be different as well? Starting at the top, right?
Well, the starting position is something you specify when you create one of these things. So it'll be up to the person who creates it to decide where it starts and where it goes, right? Because all we did with the starting position in the missile class, we just copy that. Same thing with the target. So the game is supposed to create these. When should it launch these missiles?
After a random number of ticks.
Maybe after a random number of ticks. Okay, so that's a good idea. So let's make it easy for now. So a refresh event is this thing that's ticking along. And maybe let's launch some missiles sometimes. So we'll pick a random integer, and I don't know, let's say on average you want to launch these things maybe every 2 seconds. So let's pick a random integer between 0 and 59. And if that random integer happens to be equal to 0, we'll launch a missile. So that'll happen about 1 out of every 60 times we do this, which will be about once every 2 seconds if we're ticking away at 30 frames per second. So we want to create a start location for this thing. So for that, we'll start along the top at a random location, a random x coordinate. And the y coordinate will be 0. So that's really the top of the screen. And the target, for now, since there are no bases yet in this game, let's pick a random x coordinate again at the bottom of the screen. And create this new incoming missile at that start location with that target. So let's see if these things get created. Empty range for rand range, 800, 0, minus 800. Oops. silly. Here they come. Let's get them. It was really helped not to just use a trackpad for this. No. So you already see, even without a limit on missiles, it's non-trivial. Yeah. So, thus far, we have game mechanics that work. So now the next thing I would normally do is add some bases, but we won't get those finished. So we might as well have some explosions, some sound effects. And for those, I don't know, maybe some sound effects for launching a missile. Or I don't know. Launch sound, that's pygame.mixer.sound. Launch. And in addition to a launch sound, more importantly, we want an explosion sound. What's that? Yes, it is. You're right. And the files are indeed called launch.wave, bomb.wave. So one thing I have noticed about the audio module is if you specify the wrong file name, it doesn't complain at all. It just doesn't play the sound. It just makes a clicking sound when you try and play it. Okay, so launch sound and explosion sound. We'll play the launch sound. When we create a new one of these things. And when we explode, that's when we play the explosion sound. Let's see. So indeed, we now have sound effects, explosions, incoming missiles. All we're really missing now is some bases, and we'll have this game wrapped up. So that's what we'll do on Thursday, and we'll leave it there for today.
was just wondering, is it okay if we like record our own sounds and input them in the game?
Yeah, that's great. And not